Space is vast. It's full of mystery. Among its wonders are globular clusters. Picture a giant ball of stars. That's a globular cluster. Hundreds of thousands, even millions of stars bound together. They're like cosmic cities glittering with ancient light. These clusters aren't just beautiful, they hold secrets about the universe's past. Globular clusters are some of the oldest objects we know. They offer clues about how galaxies, including our own Milky Way, formed. Imagine holding a relic from billions of years ago. That's the kind of awe these clusters inspire. They're scattered around galaxies like fireflies in the night. Studying them is like looking back in time. Their existence helps us understand the forces that shape the universe we see today. Intrigued? Let's journey deeper into these stellar spheres. Let's uncover the secrets they hold. Where do globular clusters come from? It all starts with a giant cloud of gas and dust. This cloud is huge, much bigger than our solar system. It's also dense, packed with the raw materials for stars. This is the birthplace of a globular cluster. Something triggers the cloud, maybe a nearby supernova explosion, maybe the gravitational pull of a passing galaxy. Whatever the cause, the cloud begins to collapse. As it collapses, the cloud fragments. Each fragment becomes a stellar nursery. Gravity pulls the gas and dust together, temperatures rise, pressure builds, finally a star ignites. This happens over and over again within the collapsing cloud. Thousands, even millions of stars are born. This process isn't quick, it takes millions of years. But the result is spectacular. A sparkling globular cluster, a new star city in the cosmos. Gravity doesn't stop there. It plays a crucial role in shaping the cluster. It pulls the stars together, binding them in a tight embrace. This is why globular clusters are so densely packed. Imagine cramming 1 million suns into a relatively small space. The stars in a globular cluster aren't just clumped together randomly. They're arranged in a specific way. They form a sphere with the densest concentration of stars at the center. This spherical shape is another testament to gravity's power. It's like an invisible hand sculpting the cluster into a cosmic marble. But gravity isn't the only force at play. The stars themselves are in constant motion. They orbit around the cluster's center of mass like planets around a sun. This intricate dance of stars orchestrated by gravity is what keeps a globular cluster stable for billions of years. It's a delicate balance. Too much gravity and the cluster collapses in on itself. Too little and the stars drift apart. Globular clusters are a testament to the enduring power of gravity and the intricate dance of stars it orchestrates. Let's take a closer look at a globular cluster's structure. Imagine it as a beehive. The center is the most crowded. Stars are packed tightly together. The further out you go, the more space there is between stars. This structure is a result of the cluster's formation and the relentless pull of gravity. The center, where the stars are most densely packed, is also where the oldest stars reside. These stars are like the cluster's elders, witnesses to billions of years of cosmic history. As you move away from the core, the stars get younger. This is because star formation continues in the outer regions of the cluster, albeit at a slower pace than in the early days. The outer edges of the cluster, known as the halo, are home to a mix of stars of different ages, giving astronomers a glimpse into the cluster's star-forming history. The structure of a globular cluster is not static. It evolves over time, shaped by the gravitational interactions of its stars and the influence of the galaxy it orbits. Understanding this structure is key to unraveling the mysteries of these stellar hives. Section 5. A sea of suns, counting stars in a globular cluster. How many stars are in a globular cluster? A lot. We're talking hundreds of thousands, even millions. It's like a sea of suns, each one a giant ball of burning gas. These stars aren't all the same. They come in different sizes, colors, and temperatures. Some are massive and bright, burning through their fuel quickly. These stars are relatively young. Others are smaller and fainter, sipping their fuel slowly. These are the cluster's elders, some of the oldest stars in the universe. The sheer number of stars in a globular cluster is mind-boggling. It's a challenge just to count them all. Astronomers use powerful telescopes and sophisticated techniques to study these stellar swarms. They analyze the light from the cluster, measuring its brightness and color. This helps them determine the number, types, and ages of the stars within it. Each star has a story to tell. By studying the stars in a globular cluster, astronomers can piece together the history of the cluster itself and gain insights into the evolution of stars and galaxies. Section 6, Windows to the Past, globular clusters as time capsules. Globular clusters are like time capsules from the early universe. They formed billions of years ago when the universe was young. By studying them, we can learn about conditions back then. Think of it like digging up fossils. Fossils tell us about life on Earth millions of years ago. Globular clusters do the same for the universe. The stars in globular clusters are mostly old. They formed when the universe was still figuring itself out. They contain fewer heavy elements than our Sun. This tells us that the early universe was a different place. These clusters have witnessed galactic mergers, supernova explosions, and the birth and death of countless stars. Their ancient light carries the echoes of these events, offering us a glimpse into a universe vastly different from the one we observe today. By deciphering these cosmic messages, we can gain a deeper understanding of the processes that shaped the universe and led to the formation of galaxies like our own. Section 7, Cosmic Fossils. Deciphering the universe's history. Astronomers use globular clusters to study more than just the early universe. They also provide clues about our own galaxy's formation. The Milky Way, like other spiral galaxies, likely formed from smaller galaxies merging together. Globular clusters orbiting the Milky Way like distant satellites preserve the history of these mergers. Their distribution and movements can reveal the Milky Way's past. Imagine trying to piece together a puzzle. Each globular cluster is a piece. By studying their orbits, ages, and compositions, astronomers can reconstruct the history of our galaxy's growth and evolution. They can determine when and how the Milky Way assembled its vast collection of stars, gas, and dust. Globular clusters, these cosmic fossils, hold the key to unlocking some of the biggest mysteries of the universe. They are essential tools for astronomers seeking to understand the grand cosmic narrative. Section 8, Globular Cluster Glamour, notable and unique star clusters. Some globular clusters stand out from the crowd. Omega Centauri, for example, is the largest globular cluster in the Milky Way. It's so big, it's visible to the naked eye. Imagine millions of stars packed into a space you can see without a telescope. Another standout is 47 Tucanae. It's one of the brightest globular clusters in the sky. It's known for its incredibly dense core, where stars are packed together like sardines in a can. These clusters are not just visually impressive. They also exhibit unique characteristics that intrigue astronomers. For instance, some globular clusters harbor multiple generations of stars, suggesting that star formation within these clusters can be a complex and multi-stage process. Others show evidence of exotic objects like black holes and pulsars, remnants of massive stars that have ended their lives in spectacular fashion. By studying these unique clusters, astronomers can test their theories of stellar evolution and gain a deeper understanding of the extreme environments found within these dense stellar systems. Section 9. Unraveling mysteries, globular clusters and dark matter. Globular clusters may even help us understand dark matter. Dark matter is one of the biggest mysteries in astrophysics. It doesn't emit light, but it exerts a gravitational pull. This pull affects how galaxies rotate and how clusters of galaxies behave. Astronomers can study the movements of stars in globular clusters to look for the gravitational influence of dark matter. These clusters are embedded within the Milky Way's dark matter halo. By observing how the stars in globular clusters move, astronomers can map the distribution of dark matter within and around these clusters, providing insights into the nature and properties of this elusive substance. This information is crucial for understanding the formation and evolution of galaxies, including our own. Globular clusters, once thought to be simple collections of stars, are proving to be valuable tools in the quest to unravel some of the most profound mysteries of the universe. Section 10. A universe of wonder inspiring curiosity and exploration. Globular clusters are more than just celestial objects. They are reminders of the vastness and wonder of the universe. They are windows to the past, present and future of our galaxy and the cosmos beyond. As we continue to explore these stellar spheres, we are sure to uncover even more secrets about the universe we inhabit. The next time you look up at the night sky, Imagine the countless stars, the distant galaxies, and the ancient globular clusters that grace the cosmos. Let their beauty and mystery inspire you to learn more about the universe and our place within it. The cosmos is vast, full of wonder and waiting to be explored.